Dear audience, that is a great honor and privilege to be here. And I am going to give you some short overview of three options which is listed in my title. I am sure that one presentation is not enough, that each option deserves more attention. But anyhow, I will try to limit my content and my presentation only to the ship's operation. And also I have chosen some, I would say, important aspects specifically for the service operation. And for that purpose, during the EnviSuM project, we carried out 18th survey on board the ships to gather, sometimes make some measurements and calculation for each ship regarding what was the target. And my content of the presentation is divided equally for each option. I will start very shortly with outlook for the possibilities regarding the SECA compliance. Later on, maybe a bit more I will devote to the scrubber system, which is currently, I would say, still very important, and consequently transfer our attention to the LNG as an option. And finally, what is commonly known for the conventional fuels. And then starting from this timeline of the environmental regulation, as everybody knows probably in this room, this program, several programs started 2 decades ago, and now we are more or less coming to the end, and these programs are different. Each program is generally focused on different gas component, if we are talking about the exhaust gases. And of course, this, I would say, specific side and specific aspects of programs gives the different aspects of not only the money which is going to be invested for such purposes, but also for the ships itself. And now we are in a quite important point. Here we have closed the new regulations. Everybody knows that is sulfur cap, but anyhow, in the shadow, we have also the next phase of the EDI, which was already mentioned by the Juka in the first presentation. And finally, we have also in 2021 the Tier 3 program for the nitrogen oxides compliance. Fortunately, partly, this program regarding the nitrogen oxides will be only valid for the new buildings, not for all the ships. And also, this CO2 programs will be generally focused on the new buildings. And if we will just try to summarize what kind of the possibilities we have to be compliant with the ECA regulations. Generally, what was in the title of my presentation, we divided this approach for the nitrogen oxide emission control in 2 ways. One, that is the primary, very simple one. You can remove the sulfur from the fuel and use the low sulfur fuels as primary source of the energy. And the second one is more complicated, more costly for the engines. There are the scrubbers. The name of the scrubber is unfortunately not giving the full complication and full picture of the system. Generally, the proper name, that is exhaust gas cleaning system, and later on will be used also in my presentation. That is the part which is quite important, and we know that we have different scrubbers, and not all of them are in use. For example, dry scrubber, they haven't succeed so far. We are waiting. Still, the scientists and the researchers are trying to find the proper solution regarding this drive system. And finally, quite important, there are the fuels. Yes, and we still expect that maybe in the future the LNG will become this primary source. But at the moment, I will tell a bit later what are the big obstacles so far that should be not treated in this way. And if we come to the second component, also very important, specifically for the NECA area, that is the nitrogen oxides reduction. Also, there are different approaches for that problem. As you see, if we try to eventually equip the ship which would be ready for the full ECA operation, that will be necessary to introduce quite a complex system that will contain one solution, one system for the sulfur dioxide and another one for the nitrogen oxides. One engine maker, MAN, is trying to develop the system which is based on the known system which we have already in our cars for the many years, that is exhaust gas recirculations. But this system will be only for the slow speed engines, not for all engines which we have on board the ship. And finally, that is, I would say, the outlook which will give us the picture what can be used on board the ships. Regarding the exhaust gas cleaning system, IMO has predicted in 2016 the data and estimation that was published in the reports that in 2019, exactly this year, the number of scrubbers that would be fitted on board the ship would be 7% from this figure, 24,000 ships. Apparently, we found that at the moment we have nearly half of the ships which are equipped with the scrubbers, including the new buildings also contracted for this year. This figure shows how the ship owners, ship operators reacted for the new possibility and for the new options. As you can see, generally we have the system in different types of the ships equally dispersed. There are, of course, some ships where this system is not really excited for the ship operators. For example, we have the service ships, which is, as you see, quite different. And also I would like to explain why we have the different number of scrubbers in system. If we have the multi-drive propulsion of the ship, that contains several engines. Not always you can use one scrubber. Usually that is necessary to install several scrubbers, up to 6 scrubbers. We have the ships where in one system there is 6 scrubbers on board, and that explains the number of scrubbers. And so far there are more than 40 such system makers. Even here there is not enough place to put all these scrubber makers. And also we know that there are many scrubber makers and they were not able to install any scrubber on board the ship. And so far we know that Wärtsilä, that is at the moment the primary and the most important scrubber provider, and we know that their system is one of the best at the moment. And I'm not talking about the prices, I'm not only trying to assess this technical matters which is related to such a system. And the requirements for the scrubbers is quite simple, yes, because it is related to the one that is the exhaust gas, and another one is the wash water. But regarding the wash water, we have to be sure that we are talking about the wash water which is coming out from the scrubber. It depends what is the mode of the operation. And generally, because Johan has told us a bit this relation as a concentration of two components, nitrogen oxides and the CO2 percentage concentration. This is the flexible and is dependent to the value of the equivalent sulfur contamination in the fuel. That means if we will get the necessity to be compliant with the new limit, this also value will be bigger than we have listed here. And the other area is more important, I think, because it gives for us the certainty what kind of water is coming out from the scrubber. And so far we know that generally the ship owners are opted for the open loop scrubber, which means all the water which is inside the scrubber is coming out from the scrubber. Even if we have the certain amount of the water which is cleaned, but for sure that is not even the 90%. Usually that is only a few percent of the water which is cleaned. And then you shouldn't be misled by this value or by this fact that is always stated in the papers, in the publications, that the water from the wash water from the scrubber is cleaned. That is not the truth, because for such amount of the scrubber waters that would be necessary to install, I would say, the plant, the huge plant that we are not able to do on board the ship. And finally, there are two ways of the approval for this such kind of a system. And there is a big difference between two schemes. So far, we know that mostly the ship scrubber makers, they have used this scheme B. The difference between the two schemes are quite important. In the scheme A, that is necessary to build the system in the factory, provide all the necessary certification checks and certification run, and later on install the system on board the ship and do once again this kind of the procedure. The another one, much easier to do, which is already in use, that is the system where only the monitoring system is tested and is certified. Yes, and finally the approval, which we'll see in this place, is given generally for the whole system, but anyhow only the monitoring system is certified. Why such approval differences are important? They are important because later on, if we have the system on board the ship which was not tested before, we could expect some problems. Specifically, if there is the system maker that is new on the market, that has not sufficient experience and sufficient technology that could be used on board the ship. And finally, as a product, we will get the scrubber on board, and there are some examples. These examples that is they do the same. I mean, all the scrubbers are the same, but generally you can recognize how different they could be. Not mention the system which is related to the operation of this scrubber. And our survey on board, we do this in a certain way to provide the I can say a certain set of the informations which are very important, specifically for the ship operators. Yes, and we did survey on the several vessels. These vessels are listed here, and there are the listed types of the scrubber. You can recognize that on the some vessels we have the several scrubbers. For example, here we have 4 scrubbers, and there are of course different makers. And we focused on the most important issues like efficiency of the scrubber, which is of course, quite important. Later on, we recognize also a very important issue like the consumption of the energy, which in contrary will increase the efficiency of the ships if we are talking about the operational indicator, not the design of the index, but the operational indicator, which is already also included in this convention. And finally, also, we try to assume what is the necessity to use this sodium hydroxide for the treatment if the ship is running in the closed-loop system. And not mention the sludge discharge. All these components are very important because they create the additional cost which is necessary to provide for service of such a system on board the ship. And we know that during the ship operation, there are different modes of the ship operation. And generally, we focus on the ship where the primary, the ship was running at the full load. And even if we have a hybrid scrubber, the ship owners, they use as much as possible the open loop mode, only they change the mode of operation they will come to the board. Even there are some ship operators, they have a list of the countries where is allowed the open loop operation inside the port. Maybe nobody can easily recognize that in some countries, mostly in Europe, the scrubber is allowed as an active system in port operation. There are two countries in Europe, that is the Belgium probably, and the Germany, where the scrubber is not allowed. And I know from the ship they have in the engine room the list of the countries where they can change the operation of the scrubber before entering into the port. And as you can see, we found the ships, so-called frequent flyers, between two ports, and they switch the scrubber from one mode to another one, and that is the relation where they use the different modes of operation. And we found generally the scrubber efficiency quite reasonable regarding the labels. I know that mostly the scrubber makers, they claim that efficiency is more than 98%, but this percentage is not really being accurate if we are going to take the measurement, because if we do the measurements, we can make proper assessment of the efficiency by measuring the concentration of the nitrogen oxide which is coming out from the scrubber, and of course taking into account all the sulfur content which we have in our fuel. That makes a big difference between maybe the figures which are stated in the manual or maybe in the documentation of the scrubber and which was already measured on board the ship. And we found that generally the scrubbers are very sensitive where the ship is operated with the variable speed, yes. And for that one we have also trying to assess how the scrubber behaves in such a situation. And generally, as you can see, we found that specifically this period gives some unstable parameters behavior regarding the wash water which we have in our scrubber. Then, for that purpose, I have marked the places where the scrubber was started, and even it is difficult to believe that we have some disturbances on the inlet water, which means the system is very sensitive for this kind of the measurement, and it shows instability. But anyhow, generally, all the parameters are okay, because I am showing you the parameters which are generally not exist in this log, which is created for such system for the inspections, so of course, yes. And finally, a very important issue, that is energy consumption. Generally, probably you know that engine makers, system makers, they distribute the information that the energy consumption is more or less 2% of the maximum nominal power of the main engine, or the engines which is for the scrubber design. And we found quite different figures, but our approach is more accurate. We on board recognize each equipment. For example, the equipment is shown here, and we exactly tested what is the working consumption in working conditions. Not always this value is strongly related to the engine load, because it is a quite different system, generally driven by the electrical motors, which of course include all these variables which are related rather to the pumps, to the ventilators, or the other systems which is driven by these electrical motors. Which means our approach is a bit different, because we are trying to assess the electrical load regarding the service load of the engine. And these figures, for example, which are shown here, they are made for this specific ship, when this hybrid scrubber was operated in open loop mode. And the same scrubber gives the quite different figures if the closed loop was operation. But basically, not only due to differences for this, I would say, sorry, for the parts which we have on the list, but generally by the operational period. Yes, then it explains why we have the different values. And one more example, that is example from the different ships, and in this case we have tested what is the relation between the engine load and the consumption of the scrubber system. And we found that for such a system there is no difference, which means you see we've got all the values which are generally the same. It doesn't matter if the engine load was very high or very low at the moment. And what is important, just take a look, the scrubber system gives quite important increase of the load if we will take a look at what is produced actually for this load. This is more or less nearly 30% of the total load of the electrical in the electrical net for such a system as operation. And also, what is quite important, because that was the ship where we have the closed loop operation all the time. There are some ships like this, where just take a look how incredibly high there is the consumption of the sodium hydroxide solution. That gives you the, I would say, impression how important and how high cost for such quite simple, yes, for the operation could be. And finally, I will change our attention to the another solution, the LNG. And for that purpose, we also recognize the amount of the ships which we have currently as a fueled by this kind of the fuel. And you can see that generally we know that only the LNG tankers, the main growth of the ships which are driven by this kind of the engines. And specifically, as you will see, the one engine maker, there is the, I would say, the behemoth in this case for such engine. But anyhow, we see the main problems for the LNG as a main source of the energy. Two issues. One, that is, of course, the engine itself, and another one that is gas storage. And that is at the moment the biggest obstacle that we can recognize for such vessels. And going to the ship design and ship concepts, we have, in contrary to the diesel engines, quite different engines as a potentially they can be used on board the ships. Just take a look. If we are looking for the principle of the operation, then we have two kinds of the engine. One that is working more or less similarly to the diesel process, the diesel operation, and another one that is the Otto cycle, which is more related to the engines which we have in our cars, where we have the, of course, of the combustion aviation, we have the spark plug. That is more or less the same. But also the other differences which are more important regarding these drawbacks, which is already known and already was mentioned by the Yuka, so-called the methane slip, that I'm going to show you later the measurement results. And we have also a quite different system for the gas admission to the cylinder. Yes, only one engine maker has decided to choose the, I think, most sophisticated system, that is MIN system, and they are trying to inject the gas exactly like the conventional fuel to the combustion chamber. The other ones use only as mixture, which is prepared at the inlet to the engine. That is this system, air gas mixing. And the other one, very common, I think at the moment is the most popular, where we have the multiple port injections to the inlet channel of the engine. As finally, you can say that we have two options where that is dual fuel engines, where we can use even heavy fuel oil, diesel oil instead of the LNG, and of course the LNG itself. And finally, we have also only the LNG engines. All kind of the engines now we can meet on board the ship. But just take a look. We have generally one engine maker, that is Wärtsilä, with this engine maker provides, I would say, 90% of the engines which we have on board the ship. And specifically one family is very popular. And just take a look, this engine is mostly on this LNG carriers. And for that purpose we have chosen these engines for the survey as well. And as you see, there is the engine which is developed this abbreviation, that is Lindbergh dual fuel engines. And it is quite important to understand what does it mean, this link operation. I will give you some explanation. Generally, most of the engines are operated with very low, just very close to the stoichiometric ratio between the air and fuel, and that is close to the 1, yes? Our, for example, car engines are slightly even below the 1. Generally, all the engines which we have on board as conventional engines, they operate with the ratio close to 1.2, but the Lindbergh engines are close to the 2, exactly 1.95. Yeah? That is exactly the range which is designed for this kind of the engine. And as an effect, we'll get very low, just take a look, very low concentration of the nitrogen oxide, and of course the efficiency of the engine is very high. But the operation is very, I would say, limited due to two negative aspects of this operation. One, that is misfiring, and it happens very frequent. Then the engine has to be stopped immediately by the safety system. And another one, which is more important, that is detention, as known also as a knocking system. And to provide such, I would say, very narrow air-fuel ration, the Wärtsilä provides its system with the control by means of the wastegate, which is installed in the exhaust system. Also, the other makers, they use the same on the other side, where we have the air inlet to the turbocharged engines. And here there are some measurements that we have done on board the ship, and all these red places, they are equally to the knock process, which is sometimes happen for a very short period, but anyhow, it's quite important to recognize. And for that purpose, Wärtsilä has equipped its engine with this NOx sensor to provide the proper operation and safe operation of the engine during the normal and service. Oops, it is something wrong, I'm sorry. That was not my intention, because I'm sorry, that is a mistake. I don't know why. Probably it was something with this version of the presentation which I have sent, because my intention was to show you quite important issue. Maybe I will try to explain on this slide, where we tested and we tried to validate quite important parameters of the engine, what is the specific fuel consumption. Why this fuel consumption is important? Because generally we can recognize if the engine is in good condition. That is quite important. And also, in the case of the LNG as a fuel, we can suspect that some of the fuel gets out if it's unburned. That means that will increase this methane slip, which we already have as a normal process negative side. And we were trying to find out what is the reason why we, in service, we have always, all the times, higher values of the fuel consumption against the consumption that has to be and was stated during the test cycle in the factory. It shouldn't be generally any difference. And finally, we suspect that is related to the fact that LNG has a certain properties which is not valid for the conventional fuel. These properties is expressed by the changing composition every day. If we have the LNG in our tank, then we can expect that every day they will get the different fuel. Because the difference between the evaporation of the different constituents, generally in the beginning some of the constituents will be evaporated much earlier. Later on the other one will follow. So finally, that was intention I have put here. The calorific value will change also according to this composition changes which we have in our fuel. And this trend was given in this diagram. I'm sorry, I can show you more detail, but anyhow, everything will be in our report submitted to the website of the project. And finally, regarding this methane slip, basically I can tell that no engine makers was excited if we'll try to inform him that we are going to check the methane slip. And finally, we didn't get the permission from the main engine makers, so we have chosen some engines and we measured this methane slip. And just take a look what a terrible value we've got. And there is the exemplary concentration measurement which was done on this kind of engines. And just take a look, the nitrogen emission, because that is the lean burn engines, are really very low. Yes, that should be stated quite clearly. But anyhow, much higher concentration of the methane we found. Then later on, when we calculated this emissions to the methane slip, we've got this diagram for this engine which we have. Yes, it shows that it should be our concern at the moment. Yes, if we try to assess what is the real methane slip from the LNG engines. And finally, I would like to go to the another options, that is the conventional low sulfur fuels. Taking into account the next limit which will come into force the next year, we expect that we will get the new grades of the fuel. And these new grades of the fuel are listed here. We do expect that we'll get the fuels, that the concentration, of course, the sulfur will be equally 0.5 for this global operation, and we'll get the fuels for the SECA operation. And there are no, at the moment, on the list, the fuel which is present on board and on the market, that is the hybrid fuel, but anyhow I will tell you. And also I have marked quite important parameters of the fuel, which is important due to maintenance in our ship's system while we keep in the storage tanks, and later on when the fuel is cleaned and transferred to the fuel. And also when the SECA was established in 2015, some refineries have proposed the new fuel, so-called hybrid fuels. And we collected all the different fuels, and also we have made some measurements on board where this fuel was in use. And I have marked intentionally two parameters which are extremely important for this operation and for the use on board. One, and that is the cetane index. As you see, in contrary to the normal diesel fuels, we don't have stated this cetane index. That is quite important if we try to assess if such kind of the fuel would be fit for each engine. And instead of that, we use another factor, which is given here, this calculated carbon aromatic index, and we see that fortunately there is not so big difference. According to this indicator, we can easily recognize which fuel is dangerous for our engines. And then our, of course, parameter, which is quite important, and that is the pull point. Because the pull point gives us the, I would say, valuable value for us how this fuel would be treated. Yes, and we know that this value generally creates some problems for the crew on board the ships. And I can say that so far the hybrid fuels are equally, can be equally treated as the other fuels, but anyhow I would not advise this fuel for the ships where they change the fuel very frequently. We know that this fuel exhibits very high incompatibility with the other fuel, which means that if there is an operator that operates all the time in the ECA area, that this kind of the fuel would be recommended for the constant use. But if there is the ship which is leaving the SECA area later on, doing some changes very frequently, that would be very hard to follow all the problems which we got. And we take the measurement on the ship which use all these fuels which we have as a proposal, as an option for the SECA area. These fuels are listed here, and we found there is no problem generally for the engine itself to take all these fuels. Even so, we were surprised because the engine was optimized for the HFO. The HFO gives the best figures regarding the consumption. You would believe that even if this fuel, the hybrid fuel and this distillate fuel has generally the higher the value of this, the heating value, the consumption was a bit higher than this HFO. But explains that was generally the optimization of the engine for such of the fuel. And finally, we found also that changeover procedure should be individually calculated on board the ship, individually for each engine and for each even the fuel. Even if we know there are several calculators for this kind of operation, but anyhow we found that it's necessary to provide more precise calculation regarding the current and actual fuel consumption. And that is the example where we draw the changing from one fuel to the another, and after flashing period, you can recognize that it's necessary to do such calculation for each engine where the engine is going to assist the entrance for the SECA area. And it relates also to the auxiliary engines. Is it necessary to change the fuel? That is necessary to make the proper calculation separately for the auxiliary engine itself. And finally, I would like to draw some conclusions. First one, it is quite important. We should say that generally the cleaning systems we found successfully generally as equipment that can solve the problem with the SO2 emissions. But however, we have recorded accidents like here, you can recognize, and that the system failed, yes, which means as probably Johan tell us from his measurements, maybe you can find in such examples currently in the Baltic Sea as well. That's true. The other conclusion is quite important here. We found the actual value expressed as a percentage of the service flow rate of the fuel or the load of the engine, doesn't matter because they are more or less the same, from 4.8% up to 12.85%. It is a substantial amount of energy which is needed to run this system on board the ship. And another one that is of course the efficiency, and I said before we found generally the efficiency of all systems surveyed in these ranges, yes, and there is the formula where we used for such a calculation. And the number that is the consumption of the sodium hydroxide solution, of course, because that is stated in the liters. Then you see it depends what system we have and what is the mode of the operation. We need to provide such amount that is reasonable, but this one is extremely high, yes. And you can imagine how many tons we need such bags with this dry sodium hydrocarbon to provide for the ship operation. Yes, and as a factor, we found that SOx emission for the ships which are equipped with the AGS, that is the factor which is given here. And finally, the negative side of this operation, which we found inside the scrubber. There are some deposits in the scrubber in different places, and some parts of the scrubbers are very sensitive. For example, the nozzles, which there is the picture of the nozzle which was in service on 1 year. That is a very costly part. I would say that is several hundred euros each for the replacement. And the next one, that is LNG, that we know that so far that LNG that is not the best option for the ships at all, and we found that this unwanted effect, the methane slip, is still a very serious problem that should be solved. I don't know in which way, but anyhow, that is the engine maker's problem. And because we've got quite new design of the engine, then just take a look. There are reported some heavily damaged, which we have on board the ships, and there are the examples how this damage looks like if it will happen on board the ship. Yes, there are several accidents that were happened on board the ship. And finally, I can tell that we expect that low sulfur fuel, I have listed here, they will remain the main options for the ship operators to meet the sulfur limit. But anyhow, we found that there is necessity to make some changes in design, specifically in the systems. As an example, I can show you the system which is used for the bunkering of the fuel. According to our proposal, we advise for the ship owners, if it's possible, it is quite simple change to introduce another pipeline only for the low sulfur fuel or for the high shock if two kinds of the fuel are going to be used. And that would be all from my side. Thank you very much.